soil, biodiversity, and energy garden. Okay, so biodiversity is obviously a pretty broad and nebulous term, encompassing as it does the concept of all variety of life on Earth and the way it interacts. So in terms of energy gardens, obviously the biodiversity we're dealing with is urban biodiversity, and the variety of species existing within an urban ecosystem. Humans are a major part of that urban ecosystem, and so the more we can see ourselves as a contributing factor to the function of these ecosystems, the more we can see our potential for positive change. So each species within an ecosystem has a purpose, and therefore it has value, and the health of each one contributes to the health of the whole. So there's no real standardized metric for urban biodiversity, as conventional methods of measuring biodiversity are not really applicable in these situations. The City Biodiversity Index was created in 2008 in Singapore, but that deals with biodiversity at a national level. Even though there are loads of studies and reports done on biodiversity in urban areas, there's no single index that consolidates all these biodiversity related indicators at the local level. So the question is then, what can we measure? How can we measure what's happening on these station gardens that reflects the positive environmental changes that's happening there? So species diversity is obviously a major one, and that's what we're looking into for Biodiversity Week. By carrying out baseline surveys, we can assess the species richness of each of our sites to ensure that we're constantly building on that figure. Conventional habitat surveys are mostly interested in the number of native species on a site, and then although we'll be taking that into account, native species are obviously not the mainstay of an energy garden. Whether or not that's an issue is part of the kind of ongoing debate surrounding conservation. Elements of conservation are based on selecting what could be considered an arbitrary point in the past and then working to ensure that things are kind of restored and maintained to that moment. So a country like the UK illustrates the issues with this method because of its long and embedded agricultural history. So we have hedgerows and we have heathlands, which have huge environmental importance and significance for wildlife, but they're not actually natural occurrences. They're man-made environments that have become embedded in the landscape and which wildlife has come to rely upon as a result. So the point is made to illustrate the dynamic and evolving nature of our environment. As we are operating within an urban environment, this holds even more true. So measuring the health of the energy gardens requires looking at them holistically as dynamic ecosystems in which biodiversity is actually only one part. So each element should be healthy and thus support the functioning of the others. Oh, right, we're missing a thing. Bollocks. What's happened to one of my slides? Okay, one of my slides has gone missing. It just had a picture of some soil on it. Okay, so a major part of ensuring the health of the energy gardens is factoring in the health of the soil. So that's somewhere we can have a genuinely measurable impact. So there's increasing interest in soil health. It's important to us and our environment and our need to change our current and unsustainable management of it. So feeding into this discussion with volunteers is another way we can engage with them and encourage them to engage with the gardens. So the soil's role in climate change is obviously becoming increasingly well known. Soil is the largest terrestrial store of carbon on the planet, and it stores nearly twice as much carbon as that in all living plants and the atmosphere combined. Intensive agriculture has caused arable soils to lose between 40 to 60% of their organic carbon. UK soil still contains about 10 billion tonnes of carbon, which is roughly equal to 80 years of annual greenhouse gases. But every year, England and Wales loses 2.9 million tonnes of topsoil to erosion. Over half of the soil carbon in England is contained within the top 30 centimetres of soil. So healthy soils have a teeming microbiome, which assists in decomposition and chemical filtering. And good soil structure comes from aggregates bound together by sticky root exudates, which allows for a lot of airspace in between the aggregates. So this slows down the filtration of water through it, so prevents flooding and nutrient runoff. And healthy soils support healthy trees, obviously in plants, which allows them to perform all their kind of functions that we need them to within an ecosystem, especially within cities and things, where they can contribute to reducing air temperature and absorbing pollution. And soil also provides habitats for the macrofauna, which kind of helps gardens to function, such as pollinators. So not just bees are pollinators, there are lots of like soil related macrofauna that are pollinators too. And healthy soils also facilitate the relationship of plant roots with mycorrhizal fungi. And these fungi extend the reach of a plant's roots to help them access more water and nutrients. And they protect them from pathogens and viruses and stuff. And then on the other hand, unhealthy soils allow water to percolate through really quickly, which contributes to flooding and nutrient leaching. The lack of structure means it's easily eroded, so it loses all its nutrients. And this in turn leads to the loss of all the macro and the microfauna. So the soil is actually completely inert, which means it can't be part of decomposition processes. It's not part of the nitrogen and carbon cycle. It's just not really doing anything, and it can't contribute to growing any crops or anything like that. And it's also releasing loads of carbon back into the environment. So unhealthy soil is actually like a huge issue in contributing to global warming. So urban soils. So obviously in energy gardens, we're dealing a lot with urban soils. So that's soil which has been significantly affected by anthropogenic effects. So yeah, in some ways it's kind of preferable to agricultural soil because it hasn't been as kind of overworked. So it hasn't got loads of fertilizers, and herbicides and pesticides haven't destroyed it so much. And it's not as compacted because it's not being plowed and all of that. But obviously it's got a huge amount of pollutants in it. And also we are obviously dealing with soils that are next to overground. So the previously diesel powered overground trains were emitting carbon dioxide, methane, carbon monoxide, nitrous oxides, sulfur dioxide, and hydrocarbons. And all of these really acidify the soil. So they create acidic compounds, which are then deposited in the soil and massively decrease its pH. Soil acidification then decreases the availability of any nutrients in the soil and makes plants unable to take these nutrients up. And there's also a huge amount of heavy metals in the soil and toxins, and the acidified soil is unable to hold on to these heavy metals and toxins, and so then they release them back into the atmosphere and the ecosystem. So there's a lot of concern, well, not a lot of concern, but there have been questions from commuters and volunteers and stuff about the transfer of these railway pollutants in the soil to vegetables and fruit grown on energy garden sites. So this is a really complex issue to get to the bottom of, as different plants absorb different toxins through different elements of their kind of vascular system, and they deposit them in different ways. So some of them just accumulate them in leaves and then just drop them, and some of them just kind of gather them on their roots. So it's about working out which plants will do that, and which are then absorbing them into fruits and vegetables and things. Also, even though this might seem kind of like a depressing argument, that kind of question of commuters and volunteers shows a kind of lack of understanding of the high level of pollution of food that they're buying from supermarkets anyway. So in the last 50 years, 80,000 new synthetic chemicals have been introduced into our kind of day-to-day life. 80% of treated sewage is applied to agricultural soil in the UK to improve organic matter. So it is treated, but it still contains metals, microplastics, persistent organic pollutants, and pharmaceuticals. And studies have shown that pharmaceuticals persist in the soil and they can transfer from crops to humans. So this is just the food that is being bought in supermarkets. So, you know, that's not either like very awesome. Also glyphosate, herbicide, is still used a lot in agriculture in the UK, even though it's banned in loads of countries, the UK is like really resistant to banning it. So we still have use of this until 2022 when it's supposed to be reviewed, but it's like a known carcinogen, and that's being sprayed on loads of crops as well. So phytoremediation is the good thing the energy gardens can do. So healthy soils, and specifically plant soil interactions, can remove toxins and other heavy metals from the area, or they can stabilize them so they're no longer like very damaging to the environment. So phytoremediation is a series of methods by which plants can remove or process heavy metals in the soil. So they can transport the heavy metals through the xylem, and then deposit them in their leaves, and then they like can sequester them inside their vacuoles, which protects the plant cells from the damaging effects of these heavy metals. And sometimes roots can exude these amino acids which bond with heavy metals in the soil, and then they can form stable compounds. So these heavy metals and toxins and things are not so mobile in the soil and so damaging. So the metal tolerance of plants can be increased by the activity of the mycorrhizal fungi again. And active soil microbes also decrease the toxic effect of chemicals in the soil by taking up polluting elements such as polyaromatic hydrocarbons, which is a product of burning fossil fuels, and then they convert them to forms that are less harmful. And the other one is phytodegradation, which involves the degradation of organic contaminants directly through the release of enzymes from the roots, which is kind of amazing that the plant can just exude the stuff which just totally can degrade these damaging pollutants. And as we can see from this list, it's not even like, you know, really special, unusual plants. These are like very ordinary plants that we're always planting in these gardens. And they're dealing with these like, you know, heavy metals that have actually caused a lot of trouble in the soil for ages. And there's like a lot of new research into how we can facilitate these plants to phytoremediate as like successfully as possible. Oh, and the sunflowers, as we can see at the bottom, they were actually grown at Chernobyl, and they were like dealing with radiation in the soil, and that's just a fucking, you know, bog standard sunflower doing that, which is pretty amazing. So what can we do to like support the plants to do this more and clean up the soil? So obviously it's all about that healthy plant soil interaction. So we need to keep building the soil to support the plant to do all of that. So to support the soil, it's actually like really simple processes that everyone probably does in gardens and stuff anyway. But it's about talking to volunteers about what is kind of underpinning that process and why we're doing it and how important it is to keep doing it, and kind of getting them interested into what's happening whenever we're doing that. So keeping the soil, just ensuring a lot of diversity in our plants is really important. So the wider the variety of plants on the surface, the more complex root microbiome interactions we're encouraging. So this is increasing a bigger variety of micro and macro fauna in the soil, as they feed off decomposing roots and root exudates. And through encouraging specific species, we can also prevent soil erosion. So Japanese millet is renowned for kind of being really good at preventing soil erosion due to its roots and everything. So the more variety of roots you have, the plants you have as well, as they die and decompose, you have a more nutrient-rich topsoil. So areas of vegetation in urban spaces often get dominated by single plants such as nettles or brambles, and that's due to the kind of lack of balance in the soil and the ecosystem being out of whack. And it's also often dominated by annual weeds. So in energy gardens, we're often planting perennials, which have a much deeper root system, and they have an increased root branching as well. So they have this bigger network of like fine distal roots, which encourages more mycorrhizal interactions, which is what we want. And it improves the soil structure, and the deeper roots means they're pulling the nutrients like deeper into the soil profiles, which is better. So they're affecting that structure like much lower down. And they also have a higher construction cost as well, which means that they store more carbon, which is obviously good. And as these kind of carbon-rich roots disintegrate as well, they create a much kind of more nutrient-rich humus, which is their kind of dark, organic function, like very kind of alive layer right at the top. So that's the species diversity. So mulching, you know, really basic thing to do, but super good for the soil. So depending on what we're putting on top, as that decomposes, that's getting the macro and the microfauna like really active. If you're putting on like an organic, like homemade compost, we are reintroducing loads of bacteria back into the soil. And yeah, so the more organic matter as well you have in the soil, it reduces the toxicity of some contaminants as they interact and they kind of diffuse into that kind of very alive organic matter. Keep uncovered and planted. So in urban areas, a huge problem is the covering and the sealing of the soil. So the paving over of urban gardens has jumped from like 28%, I think, like 10 years ago, to about 48% now, which is a huge problem because the soil then is not kind of, you know, performing any of its beneficial activities. There's again the runoff, which leads to flooding, and it's not absorbing carbon. It's really shit if it's covered up. So a lot of the time in overground, if it's these areas that we're gardening on, if they're just left to the management of kind of parks or overground like Network Rail or whatever, they just seal them, or they'll use loads of herbicides and fertilizers and shit, which is bad. So just by the simple process of us keeping that soil uncovered and planted, just that really basic thing, we're already providing this huge ecosystem service. And then obviously the last one is just a super basic one, but it's the fact that we're not using fertilizers, herbicides, and pesticides. So that's not just about human health, that is massively about plant and soil health, because fertilizers break down the glomalin, which is what binds the aggregates together. And over time, that's what leads to this kind of very dusty soil that has no structure. And the other thing as well is that too much fertilizer, if you have like too high nitrogen in the soil, the plants then become unable to kind of take up other nutrients kind of naturally, and they have all these micronutrients in the soil, which then the plant is unable to access, so they become more unhealthy over time. They don't produce these amino acids, so they have less protein in them as well. So they're actually like just much less healthy for us to eat as well. And what else do fertilizers do? It's bad. Oh, over time they like inhibit the photosynthetic quality of the plant, so just it's kind of diminishing its health over time. So it's just kind of a false it's false feedback that we think that fertilizers, the green revolution made us think that fertilizers was going to sort loads of shit out, but it didn't. It fucked up loads of things. But I mean, obviously it was good as well. So as we can see, healthy soil has countless benefits to plants, ecosystems, and to us. And it does take time, obviously, to build up healthy soil, but every single year that we're doing that, there is going to be a benefit. And yeah, it's just part of this positive feedback loop that we're creating in the garden. So it's just one more part of that healthy ecosystem that we're creating, that's creating this healthy whole. Cheers.